Morning, guys. I am here just giving a few of you, yes, Natty and Stalls, um, just giving you the others a few to come on out. Please just send WhatsApp messages in the group. So Natty D, send in your group, and sisters, send in your group. I'm gonna please to let them know so class are key, and them for come out now. I give another 10 minutes before I start. All right. Thanks.
All right, thanks, guys. So the messages were coming into both groups. I'm just, trying to sort my headspace as to what it is that I'm going to be doing. To facilitate both groups, I'm going to be extending the differentiation. I'm going to do a quick review of differentiation, and then what I'm going to be doing is moving into stationary points of a single variable function. And when I do the stationary point of a single variable function on the differentiation, I am going to move into another application of differentiation, but the multivariable function, and be able to calculate the stationary points of those also. So today is going to be a class filled with a lot of differentiation. So I know I'm here from 8 o'clock. I'm just giving a few more. I'm not seeing a lot of, I know this is a business class. I've invited my CAPE students because they're doing the same thing. And I'm seeing only 1, 2, 3, 4 business calculus students. And that's not good. And that's why I don't start it. But guess what? In exactly 5 minutes, if it's a 4 of those business calculus students that are there, the 4 will benefit from the class, along with my CAPE students who had class up until after 9 last night, and they are here this morning. All right, so another 5, I am ready. I told you what it is that I'm doing. So in the meantime, in these 5 minutes, look over some differentiation. It's a good time for you to get some differentiation sorted out. Then I'm going to move into some stationary points for both single variable and multivariable functions. All right, coming back.
Before you go, sir.
Sure, go ahead.
Right. What I find is that there's some issues logging in to Canvas. So some persons can't. I'm
No, we
having
don't.
that trouble, sir. But I use my
Canvas?
phone.
No, why you log on to Canvas though?
No, man. For the ECC email, some persons can't get into it
No, but why
to
Canvas?
access it.
You say log on to Canvas, but I'm wondering why Canvas?
Hold on. Dwayne text me, sir. He said that he's trying to log in, but it's saying error. And I got the same error because I can't use my laptop to log in. So I just took out my
Okay.
phone, and because I'm already in the email, that's how I got access this morning.
All right,
So
so
you
this is
say,
exactly what I want you to do. Do me a favor, please. Send a message to let them know that it is always advisable to log into their ECC account on your laptop and just connect to Zoom from there. Because they will need to authenticate themselves. There's an authentication that is even a problem. So what you need to do, and it goes for the CAPE students also, what you need to do is to just, if you're using like a laptop, and I want you to try that with a laptop for me, please. Log into your ECC email account, your Google account on your laptop, and then try to connect to the Zoom, and you should be able to go.
but that's what I'm saying, sir. That's not coming up as well because I've been trying that from yesterday.
Oh crap. Oh crap. I don't know what this is. All right. So how you got on? You using your phone, you say?
My phone, sir.
All right. Tell him to come in on him phone to or come in on one tablet. I'll have to report this so the guys can sort it out for me.
All right, I'll tell him, sir.
Thank you, honey bunches. All right, so as to doing it other students, so I shall begin. Morning again. And trust that you had a good night's rest and that you are okay. We are ready like a Freddy. All right, so the plan for today is to just go through some more differentiation. It's going to be more of a work day than anything, than a teaching day, because I've already taught you how to differentiate. So what I'm going to be doing is giving you, I'm going to be posting some questions now so that you can, okay, so that you can do some practice questions for me. Then I'm going to come into what I call stationary points of single variable functions. And then following which we will look at stationary points of multivariable functions. Stationary points of multivariable functions. So if only the system honestly has a mind of its own. Let me see if I can connect another way. I'm trying to join the meeting otherwise because it's not connecting. Okay, this one appears to be working. I just need to sign into another device, which is my sharing device. All right, so that one worked. Differentiation, all right. So as I said before, I'm just going to project some questions on differentiation. And then I want to work on it. Business Cal, did I do the product and quotient rules with you?
Yes, sir.
All right, well, thanks. I'm a little confused about that now because the CAPE students are actually on calculus now, and both of you are pretty much doing the same thing. So at times I have to be wondering which is which. All right. Questions. I noted some questions. What is it? I seem so unprepared because I don't know my system. I don't know what to do. I have the information up, but it is not sharing. Come on, I had a problem doing that. Sort that out and no. All right, so now you're there. No, it's not responding. Finally. All right, so I think I gave you some of those who didn't class last time around. I think I did that in advance. I can get into questions, extracting the questions for you. It's not working out, so let me just go this way. It's not working out, so I just want to click some other questions. Aye, aye, aye. All right, start from it, please. Here goes question one. Start from it, please. Are you okay with the black screen to the left of it, to the right of the screen? You can see the questions to the left, right?
Yes, sir.
Yes, sir.
All right, cool. I'm actually trying to do the solutions at that time, so we'll reduce the time. So I'm going to mute, start working. I give you a couple of minutes there to do these 5 questions while I do the solution.
Sir,
Yeah.
I don't understand the EX and the
Sorry. You don't understand the what?
X and the LN question.
That's question number 4 and 5.
2 to 5.
You finished question 1 already?
Yes, sir.
All right. What is the differential of e to the x?
Sir, e to the x.
Very good. What's the differential of ln x?
Sir, ln x.
1 over x. So the whole class, everybody together, the differential of e to the x is e to the x. The differential of ln x is 1 over x. All right. Now, let me start with let me do number 3 with you. Press pause, please. I know you're working, but press pause for me, please. And let us try. Oh, gosh. I struggle with this computer, Lord. Grateful. All right, so and I want all of you to promise me, both groups, to promise me that this is the last day you're going to be learning differentiation. You have to get it today. It's a commitment. I don't have any other day to go through differentiation. All right. So this is it. So I want you to catch it. Let's go. When I'm differentiating the exponential function, the differential of the exponential function is the exponential function itself. The differential of e to the x is e to the x. And then I differentiate the function. The differential of ln x is 1 over x. So let us look at number 3 for argument's sake. Number 3 says, by the way, what rule do I use for number 3?
Quotient rule.
Very good. The quotient rule, because the quotient rule, because I have a fraction, numerator and denominator. Very nice. I'm happy that you see that. Very nice. So we're not bad. We know what the quotient rule is. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. That's what it is. So let me just put that there, the denominator. And when I'm differentiating e to the x, it's just going to simply be e to the x. And then I have to differentiate what the x is. All right? And what is the differential of x squared plus minus 7?
X.
2x.
Thank you, please. Very nice. All right, so look at me project the first line of the differentiation and tell me if you are following. Guys, please, this is it. Time is against us. The denominator, 3x plus 1, I write it back. The denominator times the differentiation of the numerator. Now I need to differentiate the numerator. When I differentiate the numerator, the differential of e to the x is e to the x. It means, say, any function at all I get that is exponential and I differentiate it, I'm going to write it back exactly as it is. See here, x squared minus e to the x squared minus 7. I'm differentiating the numerator, see? E to the x squared minus 7, I write it back. When I'm differentiating the exponential function, in differentiating the exponential function, I write it back exactly what the man them give me for the exponential function. The difference now is that I must now differentiate the power. When I differentiate the power, the differential of x squared minus 7 is a constant that goes to 0. When I differentiate x squared, I'm going to get 2x here times 2x. So let's go again. The denominator times the differentiation of the numerator. When I differentiate in e to the x, it's going to be e to the x times the differential of x. And the differential of x, which is a power, is going to be 2x minus the numerator times the differentiation of the denominator, which is just simple 3, all over the denominator squares. Tell me that you see what it is that I'm doing, both groups.
Yes, sir.
Nice. Laura, Dwayne, Damian, Diana, Sachelle, I want to hear from you. Calling it.
Yes, sir. I'm straining my eyes, but I'm following.
Sir, I'm following.
Nah, Andrahan, how you stay?
Yes, sir.
All right. Okay. So, Tess, you good? No, me not hear you. Say it again.
Following.
Okay, you're following. All right. Now remember, if you're not following, please speak up. Today is the almost last day that I'm going to be doing this. We have to get this today. We have to get this today. I need to move. Honestly, I need to move. Let me go again. So we are going to be using the quotient rule. Everybody should know that we're using the quotient rule. Why are we using the quotient rule, sir? Because it is that we have a fraction. We're differentiating a fraction. Fraction, yawn, numerator, denominator. Oh, that's what they call fraction, sir? Yes. And once you differentiate in a fraction, we use a quotient rule. The quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Watch me, watch me. The denominator, I write it back. Let me spotlight this because I really want you guys to see it. When I finish these 5 questions, we all know how to differentiate. The denominator, I'm writing it back, times the differential of the numerator. Oh, the numerator is an exponential function. But the differential of an exponential function is the exponential function itself. So hold on, no, is it not charged? Why is it not charging? Oh, no, Mr. Shan, if you don't turn on the something, what you expect? Hold on, guys. This thing goes on very quickly. It don't give you much time. Okay. All right. Right. So let's go again now. So when I'm differentiating the exponential function, any exponential function, when I'm differentiating any exponential function, it is going to be the exponential function itself. But what I must do now is to differentiate what the power is. So watch me. Let's go again. The denominator. Here so. Times the differentiation of the numerator. Differentiating the exponential function is the exponential function itself times the differential of the power. See here, the differential of the power is going to be 2x. That done. Minus the numerator, write it back. Times the differentiation of the denominator. When I differentiate the denominator, I'm going to get 3. See it right here, so? All over the denominator squares, right here, so. Are you all seeing that now?
Yes, sir.
All right,
Yes.
cool. All right, so let's go. Oh, so I was wondering what it is that I was doing here now. So what I'm doing here is just fixing up. It's just fixing up the stuff as I would have it. So that you can see what is happening. So what I did here, I just multiply the 2x in front of everything. 3x plus 1, e to the x squared minus 7, minus 3 e to the x squared minus 7, all over 3x plus 1 squares. Remember, sir says to your business calculus and kid that we never ever expand the denominator. Never, never should we expand the denominator. Nope, 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 nope. A question just came into my mind. A question just came to my mind. All right, let me try this one. Copy. Question just came to my mind, and I don't know if the man then can do that, and I love to swallow the spirit. So I'm going to just be obedient and do that. I soon fix it up. Soon fix it up. I know I don't want to lose what came to mind. All right. So now, hear me out. Yes, Papa.
All right, sir. Joined a little bit later. Was having some issues accessing the email. Yes, sir. The 2x minus ex to the second minus 7. Where did he get that one? Where got that part from? I'm following up to that part. So you know the numerator over the denominator.
You're talking about this?
Yes, sir.
Where are you? Okay, all right, let's go again. Yes. Let's go again, Damian. Thanks for your question, but let's go again. Oh, so maybe a quick solution then to all of this is me just copying the class list in the those who can get the the link for the class, then just if you can't access your email to get the stuff, somebody just post the link in the class in the WhatsApp group. Then I think that may be a big solution. All right, let's go. So the question says e to the x squared minus 7 over 3x plus 1. We're utilizing the rules of differentiation, product, quotient, chain, and the power rules. All right. So you're given a function, e to the x squared minus 7 over 3x plus 1, and you're asked to differentiate the function. You're asked to differentiate the function. In differentiating the function, you must first recognize how you're going to cook the chicken. If you for fried chicken, if you for boiled chicken, if you for baked chicken, curry, fricassee, you have many ways. So you have to now decide which way is most appropriate to look after your chicken. When you see the question, you must now decide which of the rules is most appropriate to look after this. All right, let's go. It's quotient. The quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. That's what it says. Watch it now. The denominator, 3x plus 1, see it right here, sir? Times the differentiation of the numerator. When I differentiate the numerator, is an exponential function. The differential of the exponential function is the exponential function itself. Oh, that's why I write it back, sir? Yes. The differential of the exponential function is the exponential function itself. But I'm not finished yet. I have to now differentiate the power of it. Okay. That means x squared minus 7 is what you call the power, right, sir? Yes. And when I differentiate negative 7, I get 0. Why again, sir? Because it's a constant. And the differential of a constant is equal to 0. So I'm now going to be differentiating x squared. And when I differentiate x squared, I'm going to get 2x. So I'm going to be multiplying it by 2x. And then the rule says you're going to now minus it from the numerator. So I'm minusing the numerator, everything in the numerator. See it so? Everything in the numerator, I minus it, times the differential of the denominator. So I'm going to differentiate the denominator, so I'm multiplying by the 3. Because when I differentiate the denominator, I get 3 all over the denominator squares. 3x plus 1 all squares. Damien, are you okay with that so far?
Yes, sir. Yes, sir.
All right, good. Don't move yet, watch what will happen now still. For this line, all I'm doing here is just taking this 2x to multiply in front of everything. I just fixing it up. So you decide how you're gonna cook the chicken. The chicken cook. What you're gonna know is plate the food. So you try fix it up so that it looks presentable. Because them say we eat with the item first, right? And when the food palatable with the eye, the juices in the mouth start to flow and it will help with the digestion process. And I have some bio students here and can tell you more about that. So let's go. Where I was now is to tell you whenever you differentiate the exponential function, you'll always have something to factor out into the exponential function every single time. Because since the differential of the exponential function is the exponential function itself, I'll always be able to factor out the exponential function. And look at what I have. What is common here? Bam. That first term, that is common here. Bam. The second term has to be e to the x squared minus 7. So I'm taking it up because it is common. We never ever trouble the denominator. Denominator square, boom, it done. We not expand it. It's just the numerator alone. So it makes a question even easier for us to deal with. Only the numerator alone I'm interested in. Let's go. I can now go ahead and distribute something over something here to kind of fix up something here. 2 times 3x is going to be 6x squared. And 2 times -1, positive 1 is going to be 2x. So that's plus 2x. And then we have a minus 3. Let us check to see if we're correct. 2x times 3x is 6x squared. See it right here, so. And 2x times 1 is 2x. See it right here, so. I finished doing that, and I have a minus 3. So you can factorize this. I don't think there are any factors because 3 6s are 18. I can't find 2 numbers. Yes, I can. No, I can't. I can't find 2 numbers that multiply together will give me 18, but when added will give me 2. So I'm going to leave this as my final answer. Look and tell me now if you're following right there. Take home point. Very nice. The take home point is the differential of an exponential function is the exponential function itself. That's the take home message. Every single time. The differential of you get it now, Natty?
No, me, I don't get Aniki.
Oh, Aniki, okay,
Her
cool.
brother don't get.
Nice, 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 nice. All right, very nice. Now, I'm going to leave that up. I am not here to do all the questions for you. Today's a worky day. Now, I have an easier exponential function right here. So, in question number 2, which of the rules do we use question number 2 for?
So the one about the first and the second.
Yeah, tell me what name. The product rule, very good. The product rule, nice. Work the product rule for me, please, guys. Those of you who are, oh Lord Jesus. Oh my Lord, what do I do? I know some of you.
For number 4, sir, product rule I used to, right?
Yeah. All right, I'm sharing the screen like this because I know some of you are understanding and move on. So those of you who just catching it, move on to number 2. Number 2 is up the top of this page. The solution for number 3 is right here. I'm going to give you a few minutes. Then I'll come in under number 2. a few minutes and come in and do the others with you. But I want you to get some practice on your own. It's not for me to just do the questions. I want you to jerk the hands a little bit. All right, so I am here, just muting. Ouch. And start working, please. The second one? Laura Lee, you finish the second one?
It was the second one that we were to the sir?
Which one do you know?
Number one.
Number one?
Yes.
That's fine. That's fine. Are you finished with number one?
Coming down on the yes, sir.
Dwayne, how you stay? Dwayne not talk to me today. Diana, how you stay?
I'm working it out, sir. Remember, it's phone kind of small. So I think.
Okay, yeah, so you're using the phone as well. All right, cool. Do me a favor. Do you have a laptop, right, Davian? I'm doing.
Yes, sir.
All right, do me a favor, because I had to do that a while ago when my system wasn't connecting so well. When you go into the view screen on your phone, touch it. In the center of it, you're going to see a zoom with an arrow pointing downwards. Are you seeing that?
The zoom with our pointing, yeah.
You see that? Click on that. Click on the zoom, and you see the information for the class that comes up: the meeting ID and the passcode 95869794414.
Yes,
and the
sir.
passcode uppercase B, rate A, support, and so on. Use that information now and try and log in. Just join a meeting, go on your computer or your tablet and click join a meeting and put in those credentials, and you should get in on a bigger screen. Try that for me. I don't want it to retard your progress in class today. Man, cool. And the rest of you can try what I just told Dwayne, please. I want to hurry up, man. Class now got boring. You don't know where I'm not sure. Hurry up and do this something for me, man. Please. And if you're finished with one and finished with two, just continue working. Continue working. Are we finished with the questions?
Soon finished, sir.
All right, I'm right here. Cool. Continue working, guys. I get nervous now. Nobody not finish it.
So I remember tell you what I do. Honestly, 2, 4, and 5 straight one little way. So I'm gonna skip them there and do 6. And then I do 1 and 3.
Okay. Go on fiddle with the others. Go on fiddle with the others. We're getting past this, man. We're getting past this. We're getting past this. Diana M, what is it?
Still working, sir.
Still working. All right. Has everyone completed question number 1?
Yes, sir.
Is there anybody in the class that is still working on 1? Talk to me now, please. If you're still working on 1, just raise your hand for me, please. All right, so let me do number 1 then. Since you are, ouch. What's it? Don't you know that seem to bite on a Saturday morning? All right, let us do number 1. All right, so it's a quotient, and for my quotient rule, it's a denominator times the differentiation of the numerator. But the numerator is a power rule, so I will have to go ahead and do my power rule stuff. So it's a denominator times the differentiation of the numerator. Oh no, undo. Times the differentiation of the, ouch. Times the differentiation of the denominator times the differentiation of the numerator. So it's going to be that to that times that minus the numerator times the differentiation of the denominator, and the differentiation of the denominator is simply 1 all over the denominator squares. Do really nobody know? If you don't know how to sing the song, you're not good to go. Me not ask you. Watch me. Look at that and tell me. It's a denominator times the differentiation of the numerator. Remember, the numerator is going to be the power rule. It's going to be 2 times x plus 1 to the first. See it right there, sir? And then times the differentiation of the inside, which is 2, minus the numerator times the differentiation of the denominator, all over the denominator squares. Everybody agrees with that line?
Yes, sir.
If you not see it, thank you very much for agreeing. If you're not seeing it, guys, tell me.
So, sir, if me expand, I get it wrong.
If you expand what?
The top part, the 2x plus 1s. in bracket square.
No, don't expand it yet. No, yeah, don't expand it. You know why? If you look at both sides of it, tell me, say it's a 2x plus 1 on either side of the negative sign. True or false?
Yes, sir, true.
Yeah, man. So tell me now, in your words, tell me what can I do once I see the 2 of them on one side? What will be my next step?
Factor root.
Ah, yes, Johnny. Yeah, man. Very nice. Tell us, you can be
So
working up.
my eyes, I forgot to say something in power rule. That's why, man.
Yeah, man. Oh, I just get what you say now. So what you do, you expand it and then differentiate it.
Yes, sir.
Yeah, you no matter do that, man. That's too much work. And you may make mistake in that, and the question carry about 5-6 marks. And you know, one dash on the mark out of that, you want to catch all of the mark them. But you're not wrong, though, you know. I'm only trying to save face. You know, you're not wrong. You're not wrong, but very nice. So just always remember there's a power rule, eh? All right.
Right.
Good, Papa. All right. Now, so son say factor it out. And that's what we're going to be doing. Now, remember, when you're factoring, you always factor the smaller of the two. You always factor out the smaller of the two. All right, I need to write a line before that. Copy that. I'm gonna put a line in here. All right, so what I'm doing, I'm just going to multiply this 2 by this 2 to give me 4, put back the x plus 1, and put back the 2x plus 1. I don't have to put back to the first power. And then 1 times 2x plus 1 all squares is simply 2x plus 1 all squares. So remember when I'm factoring out, so this is what John Mark says. Yes, sir. My sister 2x plus 1 is in this first term, and 2x plus 1 also exists in the second term. Yes, there are 2 terms. 4 times x plus 1 times 2x plus 1 is 1 term. And this one here is another term. So when I'm factoring out what is common, I'm taking the smaller of the 2. I can't take out this one. I have to take out the 2x plus 1. So when I take out the 2x plus 1, I'm going to left with 4x plus 1 times 1 more of this, which is x plus 2x plus 1. So I took out all of this 1, and I'm taking out 1 out of the 2 of these. So I'm going to left with 1. All right. And then now I'm going to just finish off this little portion right here. So, and so 4 times x is 4x, and 4 times 1 is 4. And then this is going to become minus 2x minus 1. Look at that line and tell me if you agree with it, please.
Oh, sorry, sir. Quick question here. Track back a bit. In the, what I call that, the second line, the first dx minus y, the second 2 in the equation. You can remind me what you think by that second 2?
This one here?
One. Yes.
I have to differentiate. I mean, this is a power rule, so I have to differentiate inside of here. So.
Okay.
Man, the power rule, so I have to differentiate inside here. You follow me, Dwayne?
Yes, sir. Yes, sir. I see it now.
Mm-hmm. I like when you ask me questions here, guys. So don't feel that you bother me and so forth. Ask me the question. See to yourself. Look again, Dwayne. Y is equals to 2x plus 5 raised to the second power. And I'm trying to find dy by dx. So when I'm trying to find dy by dx, what I'm going to be doing is say 2 times 2x plus 5 to the first power. See to yourself. 2 times is obtained from the differential of what is on the inside. So no need to differentiate on the inside. So it's going to be times 2. So this 2 here out here is the differential of what is on the inside. And that's what the power rule says. So I'm differentiating everything as a whole, as I'll normally do. Y is equals to x to the n. Dy by dx is going to be equals to nx to the n minus 1. So I'm differentiating everything as a whole, but I also now have to go ahead and differentiate what is on the inside of the parentheses.
Okay.
Nice. And then now, right here now, I'm going to say (4x minus 2x is simply 2x. And 4 minus 1 is simply 3. So we're going to expand it. Nope. So 4x minus 2x is 2x. And 4 minus 1 is positive 3. My answer. Who got that one? Anybody did?
Yes, sir. So what I expand it now?
Okay, yeah, but no, but don't put yourself in an holy trouble. Nobody expand nothing.
Can you scroll up a bit, sir?
Not a problem. Oh. That's it?
Yes, sir. Yes, sir. Thanks.
Mm-hmm. We're good. Tell me if I can move on.
Yes, sir.
All right, nice. Laura, how you stayed? Dinah, how you stayed? Damian, how you stayed?
I'm good,
Good,
sir.
sir. I'm good, sir.
Mm-hmm. But you have to talk to me now, make me know so not good, you know. Because when I hear from, when I ask a question and nobody answers me, I don't know want to stay. I want to stay. But move on. All right. So now that I know that you're not good, let us move on to 3. Buckley, you all right with this one now, hon? You got this one?
Yes, sir.
Nice job. Nice job. As I said before, you know, ain't nobody know. We just need to focus a little bit more and we're good to go. I promise you. I promise you. All right, number 2. What rule do I use for number 2?
Product rule.
Very nice. The product rule. Very nice. Very nice. So the product rule says the first times the differentiation of the second plus the second times the differentiation of the first. And you will recognize again here now, Dwayne, that you also have the power rule here. Says the first times the differentiation of the second. Using the power rule, I'm going to get that to the 4th times that plus the second times the differentiation of the first. What's the differential of e to the x?
E to the x.
E to the x.
Simple. Tell me if you agree with that line.
Yes, sir.
Yeah. The only thing
Jesus.
I don't have there is the times 9 after the
Yeah.
first. Right?
Oh, you didn't put the multiplication sign right here? That's what you're saying?
No, the 9, sir. The 9
Yes.
outside.
Yes, because it's a power rule. So it's the same thing Dwayne just asked me a while ago. Yeah, man, you have to remember that here, Laura.
Sir,
All right, talk to me. Tell me what is the issue? Talk to me.
all right, for me, sir, I get the first part. All right, so the equation is e to the x and 9x minus 1 to the 5th. So I get the part, I would have 5, open bracket, 9x minus 1, close bracket to the 4th. Yes, sir. I kind of stuckish a little bit after there, so.
You're too untrue. You're not stuck nowhere because everything we tell me is correct. The only thing that you never did was to multiply it now by the differential of the inside of the parentheses, which is a 9. Yeah.
Oh.
Yeah, man. So you catch it. It's just that you reach the same place where you're at, Laura. It's the same place Dwayne was at a while ago. So you have to identify the power rule. The power rule is when you have parentheses raised to a power that is greater than 1.
Okay.
Or that is not 1, because it could also be less than 1. It could be to the minus 2 also. So once you have a parentheses and the power is not equals to 1, is a power rule. So if it is equals to -2 upon the power rule. If it equals to +2, power rule. The only time it's not the power rule is when the power is raised to the first. Outside of that, power rule. But guess what? I'm happy for where you and Dwayne are at. Because if you just keep reminding yourself that I have to multiply now by the differential of the inside, you're good to go. That's not a problem. So I'm happy for that.
Thank you, sir.
Man, cool. Tess, you know, talk to me today. Tess. The soup never tastes as good enough. Talk to me. Or you stay?
Not good. But
Me know. Me know. Me know. Cause you're going at me in my business.
they just let me play catch up that 1 week just kind of throw me off. But I'm getting it little by little. I'm getting it.
All right, please. Just say something that I need to talk about. And I'm just going to take about a minute and say, now, based on how I run my program, you know, sometimes I go one class and say, sure, if I go to class, I'm not going to miss nothing because the teacher not teach. That don't happen in the session. Nobody can say that about my session. You're crazy? You're fret. Say, I forgot my session class every day because my session are going to move. So I understand your situation with the Wi-Fi and support and so on, but see if you can put in some work over the weekend. Yeah? Your mom?
Sir, one question though, as it relates to even the recordings, I don't know.
I'm having issues with the recording. I have been posting my CAPE students, well, see them in another group where you can ask them if they think on truth not tell. The recordings are posted, but the videos are not showing. And I know, I think it was Laura who reminded me, still no resolution to it just yet, but I'm hoping that by before the weekend is out, I can get it. It's not you alone. I'm teaching you, a Calculus 2, and my CAPE students, and all of them that are sent out, that is what is happening. So I'm getting help to see if there is an issue. So by this, before the weekend is out, I should have positive news for you all. Oh, and
okay,
incidentally,
so help a lot in terms of refreshing.
Yeah, man. And incidentally, what I have decided to do is to give you the mid-semester exam after the Easter break. And my CAPE students, I've decided to give you your CAPE exam also after the Easter break so that you can get, you know, use Good Friday after you go to church and praise Jesus. Easter Monday after thanking for raising from the dead and, you know, being in our lives. After we do all of the wonderful stuff for Easter, we're going to spend some quality time doing some serious schoolwork. So that is the thinking behind me putting off the mid-semester and the mock exam for you guys respectively, so that you can get some more work done up. So please, you can't disappoint me. Oh, that song. Or you want it next week?
We'll be having class next week, sir?
I talk through the holiday, don't. No, there's no class. There's no class because it's next week. Next week is Good Saturday, don't.
Yes, sir.
Yes, sir.
Well, you must pray for me here. All right, let's go. All right, so now where are we? So again, it's the first times the differentiation of the second. The second is a power rule, so it's 5 times 9x minus 1 to the 4th. And remember now we have to differentiate on the inside, which is 9, plus the second times the differentiation of the first. The differential of e to the x is e to the x. You know what I'm going to do? You know what I'm going to do? I'm going to put it right here, so times 1. Then, sir, I have to put the times 1. I put the times 1 because I want you to know that I'm differentiating the power x up here to get my 1. That's what we mean by the differential of the exponential function is the exponential function itself. All right. Let me. Oh goodness, can I find that book, though? Can I? All right, I'm going to be looking for a calculus book. You see, and I'm going to see if I can find a couple pages with just some differential question, and see if I can also find a page with the answer. The problem is I can write a lot of questions for you, but it's like, oh no, I write the question, I have to sit down and do them myself. Take up a lot of time. So I'm going to see if I can find some questions in a textbook on differentiation with the different rules. And I'm going to see if I can find the answers also. And I'm going to drop it in the WhatsApp groups for you to work it. Business calculus, be thankful. The CAPE students have to also differentiate trigonometric functions. You don't. So I'm not doing any trigonometric functions in class because you guys don't need to do it. So when I'm sending you those questions, Cape students, I'm going to send you some trigonometric function ones also, because the differentiation is not bad. Once you understand the differentiation is good enough, you're good to go. Easy 20 marks, Cape students, because you can get one full question on differentiation, you can get on its application, you can get one full question on integration and its application, and you get 20 marks per question, or 25, which one? I think for 20 or 25. I put 25 in 25 marks.
Sir,
Easy.
what I'm saying is I could just learn differentiation and nothing else, right? Yeah. You can get me like I'll pass.
No, but it's a complete paper. You have to do 6 questions. Paper is compulsory. So the Cape students, you get 6 questions and you have to do all 6 questions. And the business calculus students will get 3 questions to do all 3. So business calculus, you are going to get 3 questions at 20 marks each, plus 20 multiple choice questions. Cape students, you're going to get 6 questions each, 2 questions on each module, and I don't know if it's 45 or 50 multiple choice, but you get or 60 multiple choice. You can get enough multiple choice. It's either 45 multiple choice or 60. I need to double check. Cape students. So you can get 2 questions on calculus. Right about now, only can answer the 2 questions and well, 1 full question on calculus, because I don't start integration with any of you yet. All right? And then now for the module 1, you should be able to answer both questions already for module 1. So you put up 50 marks right there, so. And then you put up 75 marks, so you can understand the differentiation. And what I'm saying to you, we're going to bank the other 25 marks for the integration. And then now, remember, Cape students, I'm going to be crashing the other module in a couple of weeks. So let us see how much we can bank out of the 50 marks for there. So, but if you can bank all the questions for module 1 and module 2, then you can't fail the course. And the same thing for the Cape students. I mean, the business calculus students, so they can't fail. All right, let's go. So now we're going to fix up, and I'm going to call this 5. No, 9-5 and a 45. Oh, I'm doing 9-5. The coffee now working in the morning, you know. 9-5 is 45. I have to stop drinking it. All right. So look at what I did. 9 times 5 is 45. E to the x, 9x minus 1 to the 4th. And e to the x times 1 is simply e to the x times 9x minus 1 to the 5th. Now remember, sir always say to, hold on there, something right? The first times the differential with the second plus the second times the difference. Whoa, we have enough things that we can factor out.
Yes, sir. EX, sir.
Yeah, we have more than that too. We have
So 9x minus 1.
to the 4th. Can we take out the smaller of the 2? So look at what we have. So e to the x can come out because it's common to both, and 9x minus 1 to the 4th can come out to both because we're taking the small of the 2. So I'm going to be left with 45 on this side, and I'm going to be left with just 1 of the 9x minus 1. Tell me if you see that.
Yes, sir.
Nice. Look at that, guys. Tell me if you agree with me. And I hope you do.
Sir, if me never do the part, them would lose 1 mark.
Hmm?
If I didn't do that last step, I'll do one more.
This factorization down here, so the 44 plus 9x?
No, the one before that. I only have the third from the bottom.
You only have this line?
Yes, sir.
Yeah, man, the question incomplete, man. You have to fix it up, man. And it's like you cooking a food and forget to put the vegetable with it. Or the little gravy on the side. Or forgive me one knife and fork. Yeah. But I'm happy that you got to this line. This is very nice, very good. Laura Boo, how you stay? Better at this one now?
Following, sir.
Very nice. I'm happy about that. All right. What time is this? 10 o'clock. All right. So I'm going to spend an hour on one topic and an hour on the other topic. Let us go. So we did number 3. We have 4 to look at now. So this is a product. So this one now involves the natural logarithm function. Now, hear me out. You have to remember that the exponential function, when I differentiate the exponential function, I get the exponential function back. When I differentiate the exponential function, I get back the exponential function. You have to remember that. When I differentiate the exponential function, I will get back the exponential function. The differential of e to the x is e to the x. The differential of the exponential function is the exponential function times the differential of the power. When I differentiate the natural logarithm ln function, so one is exponential, one is logarithm. When I differentiate ln x, I am going to get 1 over x times the differential of x. When I differentiate the natural logarithm function, ln x, I'm going to get 1 over x times the differential of x. So 1 over x, when I differentiate it, I'm going to get, when I differentiate ln x, I'm going to get 1 over x. Very important. When I differentiate ln x, I get 1 over x. All right, watch me. Which rule do I use for this one?
Product.
Very good. Product rule. Because something is being multiplied by something. So I'm using a product rule. I'm using a product rule. Something is being multiplied by something. I'm using the product rule. All right, on your mark, get set, let us go. Product rule says the first times the differential of the second. The differential of the natural logarithm function. The differential of ln x is 1 over x. So I'm going to have 1 over 4x, 4 minus 3x. You see how easy it is? The differential of the logarithm function is the logarithm function itself. I mean, 1 over x, 1 over the function. But guess what now? I have to multiply it by the differential of what is contained in the parentheses. And the differential of 4 minus 3x is going to be minus 3. Plus the second times the differential of the first. The differential of e to the x is e to the x times the differential of the power. So it's going to be 3e to the 3x. Look at that. Let's go. Don't scream it. The first, see it right here, so. The first is e to the 3x. The first times the differential of the second. When I differentiate ln x, I'm going to get 1 over x. So it's going to be 1 over all of 4 minus 3x. That's all it is, you know. When I differentiate the ln function, it's going to be 1 over the function. But I have to differentiate the function now and times it by it. So I put 1 over the function. I'm going to differentiate the function. The differential of 4 is 0 because it's a constant. And then the differential of negative 3x is going to be negative 3. See here? I times it by the differential of the function. Then I go to the plus the second times the differentiation of the first. When I differentiate the first, the differential of e to the x is e to the x. So see, I write it back, e to the 3x. But I have to differentiate the power now. And the differential of 3x is going to be 3. I want to just write it in the form so that you see where how I get it, right? So it's plus the second times the differentiation of the first. The differential of e to the x is e to the x, and then times it by the differential of the power. All right, so that is that piece. Talk to me. Are you seeing it? Is there something that you're not seeing? You're uncomfortable with something? Speak to me.
Sir.
Go ahead, please. You're very low though.
Sir, what I did was to put what's in the bracket. I called that the second, and the e to the 3x ln, I had that as the first.
No problem. No problem. Suppose you get the same answer. No problem. All right, so I'm just fixing up right here. I'm putting all of that function there. The only thing that is common here is really e to the 3x. The only thing that is common is e to the 3x. So I'm factoring out e to the 3x. And that's what I get for my answer. Look at it and tell me if you agree or disagree.
Sir?
Yeah, I'm hearing you. Hold on. One LA chapter pass. Hold on. A very noisy LA chapter. All right, run it now.
So there's a -3 we have in the first step. Does that represent the power rule?
This -3 right here, sir?
Yes, sir.
No, not the power rule, you know. Remember, when I'm differentiating the natural logarithm, it's going to be 1 over x, but I have to 1 over the function, but I have to differentiate the function now. So ln is going to be 1 over, see, look here. Let me spotlight it so you all can see. This conversation will benefit somebody else. I'm differentiating ln 4 minus 3x. ln 4 minus 3x. So the differential of ln 4 minus 3x, the differential of ln x is 1 over x. So I'm going to have 1 over 4 minus 3x. See here, so? That is the differential of ln x, 1 over 4 minus 3x. But I have to differentiate what is inside the parentheses. I have to differentiate what is inside the parentheses. And differentiating what is inside here, differential of 4 is 0. Why, sir? Constant. It's constant, 0. And then times the differential of negative 3x, which is going to be negative 3.
Okay, sir. So when you use a power rule?
When I use a power rule?
Yeah.
When I have one function that is raised to a power greater, other than 1.
Okay, sir.
No, don't move yet. It's like when I have 9x minus 1 to the 5th power.
Yes,
power
sir.
rule. Power rule. And if they have 9x minus 1 to the negative 5 power, still power rule. Power rule is anything that is raised to a number that is not 1. You see this here, so? 3x plus 1, that is raised exactly to the first power, if I put it in parentheses, is not power rule. So power rule is when I have parentheses that is raised to a power greater than 1. That is not 1. Let me not say greater than 1 because it could also be negative. That is not equals to 1. So that's how you identify it. Follow me?
Yes, sir.
Anybody did 5?
Well, I almost get number 4 correct if it wasn't for the power rule thing.
Sir, attempt it.
You almost get number 4 correct. Okay. What was the problem with it? Why didn't you get it? Talk to me now. You say you almost got number 4, but something about the power rule.
Oh, it was the power rule, sir. I didn't know that I was supposed to do that for it.
Okay, yeah, man. You have to multiply by the differential of the inside of the parentheses also. All right. Did anybody do number 5?
Sir, I did it.
Nice. Oh, welcome. All right, so let us go through number 5. Número 5. Número 5. So it's gonna be, this is a quotient rule, don't?
No.
No, sir.
What rule is this?
Product.
When do I use a quotient rule?
When you have something is being divided, fraction.
When I have a fraction, right? When I have a fraction, I use a quotient. When I'm multiplying something with something, I use a product. Now, I'm going to tell you a secret. For both groups, K and C and CCCJ, that's what I expect them to give you. A combination of product and quotient. Because the man them and power rule. You may get a chain rule question, but if you get a chain rule question, it's going to be a chain rule question that will involve maybe a product, a quotient, or something with the power. Because the aim is to make sure that you understand how to manipulate these rules. So expect one of those something in the something. Real talk. All right, let's go.
Yes, Papa. Internet that chip in and chip out. Where's the quotient rule is again? Explain it.
Fraction. Once we have one numerator and one denominator, quotient.
All right.
Once we have something multiply by something, product. Catch that?
Yeah, man.
I'm sure that's a welcome to coming. We just come to class. That is. Let's move right along. But very good. So this here is the product rule. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. I tell you the amount of time he said this, only supposed to can write one different tune to it. And you're supposed to be able to do these things in mentally now, you know. It's not hard. ln x is 1 over x, 1 over 5x. 1 over 5x times the differential of 5x, which is 5.
Copy and paste. All right, so look at it more. It's the first ln 5x right here, so times the differentiation of the second. The second is this one here. Chanel, what rule is this? Laura, what rule is this? Dwayne, what rule is this?
Quotient, sir.
Laura, look on something. What rule is this? Look at what I'm circling.
Sir, I was distracted. I'm so sorry. I was distracted, sir. It's the
What
power
rule is this? Power rule. Yeah, man, the power rule. So, Shan, or me, or Nelia, the power rule, how you identify the power rule, I'm just saying this for emphasis. How you identify the power rule again is that you're going to be looking for a function that is contained in parentheses that is raised to a power other than 1. A function in a parentheses raised to a power other than 1. That's what the power rule is. So it's the first, which is ln 5x, times the differentiation of the second power rule, 5 times all of this raised to the 4th power. But remember, I have to differentiate the inside of the parentheses, which is going to be 12x. Plus the second, all of the second times the differentiation of the first. When I differentiate ln 5x, the differential of ln x is 1 over x. So the differential of ln 5x is going to be 1 over 5x. But I have to differentiate the function, which is 5x. And the differential of 5x is going to be 5. All right? And you recognize that those will cancel out. So I'm just going to have 1 over x. Times 7 is 60. Yeah. The one I kind of look. Oh, okay. I see it. So watch me now. 12 times 5 is 60. Not this 5x, you know. Because this 5x is a function, we can't trouble it. So it's this 5 times this 12x going to give me 60x. And I write about my ln 5x. Remember, I can't touch that. And then I'm going to write my 6x squared minus 3 to the 4th power. This 5 cancels this 5, leave me 1 over x. 1 over x times all of this is all of this over x. But I can factor out 6x squared minus 3 to the 4th power. I'm factoring out the smaller of the two. So you always have to factor out? Yes. You're presenting your work in a manner that is presentable. All right. I can go a little further with this one. I can go a little further with this one. And I think I'm going to go a little further with this one. Copy. Paste. Six. Why the mosquito here this morning? Having a field day this morning. Look at that and tell me if you agree. Give me half a second. Look at that one. Look at the final answer there. Was somebody calling me?
No, sir.
Okay, I just went
Sir,
to.
but I got up to the second line from the bottom.
You got up to the second line from the bottom.
Same. You see how you get 6x minus 3x.
Oh, you got up to here. Oh,
Yes,
yeah, man, that's
sir.
fine. Yeah, man,
The
that's
6x
okay.
the 6x squared would be over x as well. So you just cancel out the x from the
Very good.
x squared and the
Very good. Very good. Very good. So the question is now that I'm hearing, then, sir, what if I did only leave it as the line before the second to last line? Would I get the full marks? And the answer is yes. I would give it the full marks, and I think CXC will also give it the full marks. CCCG and CXC will give it the full marks. I'm only showing you what can happen. So yes, so this part is fine, but remember now, as I think that was Shanti and Tanil coming, that 6x squared is over x, and the negative 3 is also over the x. So because I can cancel out something here, I'm canceling that to give me this and that. So if you put it as this, leave your answer as this. Let me put this in blue to show you that you're not right. I mean, you're not wrong. Whichever one, you get the full marks. All right, finally, I heard Buckley said that she should do this one. I wanted to change it. That's why I said soon come, but because she did this one, she said she went and did number 6. Let me do number 6. Number 6 is just me flipping number 3. All right, but nonetheless, there's a point I'm trying to bring across in this one. I think I brought across that point to the CAPE students on Wednesday when I met with them. I need to bring across that point to you, business calculus. Now, in this here case, the denominator is a fraction again. So once you have a fraction, you use the quotient rule. The quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Let's go. So it's going to be the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. All right. Look at that. Tell me if you agree with me. Buckley, come talk to me now. Tell me if you agree with me. Denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator. Bam, 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 over the numerator. Okay. Look at that and tell me if you see it.
Yes, sir.
And then let me go for those of you who may not be seeing it. The denominator, which is this, times the differentiation of the numerator. When I differentiate the numerator, I'm going to get 3 minus the numerator, which is 3x plus 1, times the differentiation of the denominator, which is e to the x squared minus 7. The differentiation of the exponential function is the exponential function itself times the differentiation of the power. So this is the exponential function itself times the differentiation of the power, which is going to be 2x over the denominator squares. So that now is just going to be 3 in front of that. And then this is going to be, call that 2x. All right, so I'm not going to speak to the CAPE students at this point in time because I know they know. My question now is to the business calculus students. You would have done this in pre-calculus. A to the m raised to the nth power is a to the mn. A to the m raised to the nth power is going to be equal to a to the m times n. A to the m raised to the nth power is going to be equal to a to the m times n. So I'm multiplying both powers. So that's why I have this 2 in front of the 2 you're out here. So now I'm going to multiply in the e, is a power alone that they multiply. It's a power alone is going to multiply. So it's going to multiply 2 times all of that. All right. Are you with me? Hello, somebody?
Yes, sir. Yes, sir.
Yeah, man. Talk to the teacher then, man. Talk to the teacher. Talk to the teacher. And all right, so look at that. Now, I'm seeing what the question is asking. And even though what I told you a while ago is correct, I'm going to undo something so that you can see what is happening. What I told you just now is correct, but I'm undoing something for a particular purpose. All right, so what I told you here is correct, but I'm undoing it, and I'm going to tell you why I'm undoing it. So I'm putting back the e, I'm putting back this something squared out here. And the reason I'm doing that is because I recognize I can factor out one of those from the numerator. E to the x squared minus 7 is common to both, and it is also common in the denominator. So I'm going to use this one to cancel one of them in the denominator. So even though what I told you just now is correct, I am undoing it because I can factor out something from the numerator into the denominator. Can you see that?
Yes, sir.
Yes, sir.
All right, cool, and thanks. I did this because the CAPE students, the CAPE students are supposed to do the trigonometric function, and something came to mind when I was doing something that I didn't show them about, like sine squared or cosine squared. So I gave them a question on that, which is exactly the same thing that I'm giving to you, but I can't give you sine or cosine because that's not on your syllabus. So I have to give you something with a power, when you're squaring the power, to know how the power is squared. So if I didn't have anything in the numerator to factor out, then the a to the m times a to the m raised to the nth power equals a to the mn will hold firm. All right. All right, let me just fix up something. Where am I now, Lord? Okay, so undo that. So I can cancel that into one of this. And say 3 times 2 is 6. I'm going to get 6x squared. And 2 times 1 is 2. So negative 2x. Look and tell me if you agree with that. I'm canceling out this one with one of these to leave just this one. And 3 minus 2x times negative 2x times 3x is negative 6x squares. And negative 2x times and negative 1, a positive 1 is going to be negative 2x. So do you agree with this one?
Yes, sir.
Yes, sir.
Nice. Tess, I feel like I run when I leave you.
Sir, so some have you, but well, the answer in the right order, sir, but then have everything else before that. Have the same things than what you have, but not like what you have.
You have the negative 6x first?
Yes. No,
No
sir,
problem.
the answer I have it in the right order. The answer in the right order. But everything
Mm-hmm.
before the answer, the in and I say,
And that's fine. But you get everything in red, right?
yes, sir.
You're good to go, man. You know, I can say I'm not going down the road. And I can say, nah, go down the road. It translates to be the same thing, don't? I think so. Yeah, man. Very nice. Very nice. All right. Now, I spent.
So why you forget the square, the sign,
Which sign? I mean, so
the
something?
denominator?
The square? Or because I cancel one of these up here, so. This one, cancel with one of them down here, so.
Oh,
Cancel one of them down here. That's why I told you that I reverted to not writing like that, but I wanted to show you, just like what I showed you on Wednesday. With the sine squared, with the sine x all squares is sine squares. I wanted to show them the BIS calculus that, you know, when I'm squaring this is a recall from pre-calculus. A to the m raised to the nth power is equal to a to the m times n. Very important. All right. Truth is, I spent much longer than I intended to on a review of my differentiation. I finished differentiation, you know. Finished differentiation fully. Finished differentiation. And I've spent more than the time that I really intended to spend on the differentiation. I don't regret it though. But here's my question. Natty D, mute for me, please. All right, so this exercise that we just went through in doing these 6 questions, interspersed with my explanation. Are you okay now?
Yes,
Yes,
and I'm much
sir.
better place.
Very nice. And as I said before, I'm going to dig up some questions and send off, and I expect you guys to do it just to concretize the stuff. I mean, even at the expense of me calling you in one Sunday after church and say, come, service done. Make me put in a little 1 hour, I will do it. But I had to spend the time on the differentiation to get you to where I want you to be. So thank you. I give you a 2 minutes break because I'm starting something else. Differentiation finish, you know. Matter of fact, let me just show you something, because you don't believe me. This is a question we just did, right?
Yes, sir.
All right, look here. Down here, it says page 28 of 28. It means I'm not more on this thing. So I finished unit 5 with you business calculus. I finished unit 5 with you, which is differentiation. I'm closing out that stuff. I've finished unit 5 with you. I'm starting unit 6. Why do I have that there? Oh, I have cost function to do. Both groups are doing cost function. Yourself and the CAPE students are doing cost function. I can't teach a cost function yet. I have to jump over cost function because I may need integration to the cost function. So it don't make sense to do the cost function yet. So the CAPE students are also doing cost function. I'm going to press that and pause. Hey, listen to me. Don't be surprised if one day next week, call on in for like a late evening class. Yeah? Be on the lookout. I'm notorious for that. Matter of fact, let me just get this out of the way from now. Business calculus, you're predominantly weekend students, right? Do you have a class on a Wednesday afternoon, Wednesday evening?
No, sir.
Yes, sir.
What time is class? Who said yes? What time is class finished? The yes person.
From 5 to 9.
Dang. All right. All right, I'll think about it. I know I can put in a class with my CAPE students because they are day students. I'm going to schedule a class before the Thursday. I'm hoping I should be able to. And then I'm going to invite some of you to come in. All right, let's go.
Next week, sir.
Yeah, one day next week, yeah. I don't want to do.
Is there any holiday next week?
Yeah, man, there's Holy Thursday. There's no class on Holy Thursday. There's no class on Good Friday. There's no class on Good Saturday. There's no class on Good Sunday, and there's no class on Easter Monday. And it will come back to school, regular business on the 19th, the Tuesday.
So we can't have class the Friday.
Well, maybe not, because I know I'm going to be busy with church. I'm going to go to church, and then I'm going to tie down and come sleep, and then I'm going to go and reflect. So I know Friday will be out, period. Saturday could work, possibly. But the truth of the matter, if it can work on Saturday, I can't use any of the Excelsior links because they're not set. It's a Methodist institution, and they're not sending out any links. So we have to go use a 40-minute something, and every time it cut off, we have to come back. So I can't think about that time. I don't know if anything is going to come up, but if nothing comes up for me, we could squeeze in a little class. All right? We could squeeze
there was
something.
no class planned for the Saturday, sir. There was no class scheduled for the Saturday. Is that it?
I think so. There's no scheduled class for Saturday, yeah, because it's Easter break.
Okay. Well, being that we have classes on Saturday, probably that would be something that would be already accustomed to.
All right, as I said before, I will let you know. Okay. Where are we? I am on to now. We're not doing badly, business calculus. We have about 3 more topics to finish off. We're not doing badly. And of the 3 topics to finish off with you, 2 of the topics the calculus, the CAPE students are doing multivariable function and integration. Yeah, man, we're not going bad. And cost function, no. We have 1, 2, 3, 4 topics left. And of the 4 topics, they are doing 3 of the 4 topics. So they will be with you for some time. And they don't have enough time because for them something finished soon. But anyhow, let's go.
Sir?
All right. Yes, honey.
Yes, sir. EducaSoft is nothing like what you teach in class, sir.
Don't say that. That's not true. That's not.
Sir, it's true.
That's not true. It's not true. It's not true.
Sir.
It's not true. It's not true. Laura, you see where you start, Laura? It's not true. It's not true. In Jesus' name, it's not true. Mm-mm.
Sir,
Sir,
I'm
100% agree. Facts. Real true.
All right, I'm going to tell you what is the problem. You see, I don't know how CXC can set them question, you know. I don't know how CCCJ can set them question. You are accustomed to how I write my question. You see like those 6 questions we did in class a while ago? Where me get them 6 questions from? Hello? The 6 differentiation question, Laura, that we just did in class, where I got them from?
Your brain, sir.
I want
Out of my head, my brain. So now, some troublesome person from the other community college may say, we're not going to give them the question there. We're going to tell them, say, a farmer plants sweet potato and Irish potato. His produce at the end of the month is represented by the equation y equals e to the x times ln x. Find the differentiation of that and determine how much at that point in and the same differentiation question, you know. But no, what the man them do is put them in a words. But so we can do it? Of course you can. Because it them said to you, find the differential. You know how to differentiate something because I'm teaching you conceptually. So you know, say, e to the x times ln x, that is a product rule. The first times the second plus the second times the first. You differentiate it. And then them say to you, at a point when x equals something, right? So they want to find the gradient when sweet potato is at 4. So you plug in 4 into the differential and tell them, say, guess what? This is the amount of sweet potato that you then get, or the amount of pounds of sweet potato you then get at this particular point along the stretch of the sweet potato hill where you grow. Those are how we do this stuff. But guess what? Educasoft may put the question in such a way that then Indians are bright people, you know, brighter than we. So we just have to be flexible with how we do the question. Sometimes we talk about textbook and we don't know what the textbook has said. But we have to get familiar with it. So it's not that it's different. It is different in how it is that I word my question. But I'm sure if I were the one writing the question on Educasoft, it would be something that is similar. So it's just work with it, man. You're good to go. Let's go. Now, let me confess something. This is calculus. Last night in class, I placed my CAPE students under pressure. Maybe last night was the first pressure class that they faced. We did quite a bit of concepts in class. I'm going to do the same thing with you just now. I'm going to do a piece of a question and then jump into an example or single variable function, stationary points. Now, Mr. Whom can trouble now. Is the other one doing him? Him swear say man a wicked driver, you know. But the truth of the matter is Dwayne can't drive like me. I mash him up any day on the road. You understand? I mean, I'm not talking about driving fast to go kill off yourself, you know. No. Because Dwayne never tell me, he said, sorry, no, say the other day I go to work, you know. I remember saying, I leave the stove on. I mean, catch up on the road, you know, I just fling the car around and just turn back and just go turn off the stove and then go back. I know, so I catch work early, sir. And hear me to do, you know. So the car never stop. He said, stop us, sir. But just take a right about turn and just turn on the car. I said, the car stop, sir. The car never stop, sir, because me tell you, so I just fling the car around the road. And go on. So the moment you hear the earths, it means they stop at some point in time. He had to stop even for a nanosecond in order to change its direction. That is what stationary point is. Stationary point or critical point or turning point is what we call it. It is that point when your direction has changed. You're going into one direction and so happen that you end up going into another direction. That's what we mean when we speak of critical point, stationary point, or turning point. All of those points are synonymous. Some questions may say stationary point. Other questions may say critical point. Yet another question may say turning point. Means the same thing. All right? Now, what I want you to note is if y is equal to f of x, or if f of x is equal to y, same difference. When I'm finding my first derivative, it's going to be f dash of x or dy by dx. It's going to be f dash of x or dy by dx. The second derivative is going to be f double dash of x or d squared y by dx squared. Cape students, you are required to go up to, I think, only the second derivative. CCCJ students, you can go up to the third derivative. So they can give you a function and ask you to find d cubed y by dx cubed, no problem. Differentiate it one time, get the answer. Differentiate the answer one more time, get d squared y by dx squared. Differentiate that one more time to get d cubed y by dx cubed. All right, so it's not a problem. All right, now to determine the stationary point, one, you're going to differentiate the function. You're going to differentiate the given function. Then you're going to set the differential equal to 0 and solve for the unknown. This will give you your critical values. Your critical values. Then you're going to substitute your critical values into the original function. Has to be the original function. Can't overemphasize that it is the original function that you're substituting in. And when you substitute into the original function, then you're going to end up with your stationary points. So together, those are be known as stationary points, critical points, or turning points. As easy as that. To classify the nature of the turning points, I have two methods. Method one, I can find the second derivative. I can find the second derivative. In calculus 2 students, you would see me calling method, what I have here, method 2 as method 1 last night, but you just know that there are two methods. So one of the methods is to go ahead and find the second derivative. And when you find the second derivative, you're going to substitute your critical values into the function of the second derivative to investigate the nature of the turning point. To investigate the nature of the turning point. When we're doing limits, we look at the nature, the intuitive approach. We looked at a value. We looked at the right of that value. Sorry, excuse me. We looked at the right of that value, and we also looked at the left of that value. So we're investigating what is happening in that function. That's exactly what we're going to be doing here. If it is positive, we say it's a relative minimum. If it is negative, we say it's a relative maximum. If it's positive, that means it's greater than 0. It's a relative minimum. If it is negative, that means it's less than 0. We have a relative maximum. If it is equal to 0, then we have a saddle point. So those are 3 points that you will use in your classification: a maximum point, a minimum point, or a saddle point. And if you want to picture what a saddle point looks like, think of a saddle that you put on a horse. So if it's positive, if the result of my d squared y by dx squared is positive, then I have a relative minimum. If it is negative, I'll have a relative maximum. If it's equal to 0, then I have a saddle point. And I'll show you the graphical method sometime later, as explained here. And then if I'm looking at the intercept, to evaluate the y-intercept, I'm going to put x equals 0. And to evaluate the x-intercept, I put y equals 0. So what I do is put the other one equals to 0. So I can't be asked to find the y-intercept and put y equals 0. No. If it is a y-intercept, that means x equals 0. And if it's an x-intercept, it means y equals 0. So it's the other one that is equal to 0. Fair enough? No answer?
Yes, sir.
Okay. And then now to do the point of inflection. My point of inflection, I'm going to be finding the second derivative. I'm going to be setting the second derivative equals to 0. Then I'm going to solve for the value of x. Then I'm going to solve for the value of x. When I solve for the value of x, or the unknown, I'm going to substitute that value into the original function. When I substitute it into the original function, I'm going to get the corresponding value of y. And that will give me my point of inflection. Please note, the point of inflection occurs between two critical points, and it is known as a midpoint. All right? So if the function has only one critical point, then it can't calculate a point of inflection. You must have two critical points, at least two critical points, to calculate the point of inflection. All right. So confessing now, the business calculus students, sorry, the CAPE students will know exactly what I'm talking about because we spent time on this last night. I couldn't invite you to class last night because I know you guys were having class. And in a Friday night you're not having class, you can let me know so I can just see what I'm doing with the CAPE students and invite you to their class. Because we meet 5:30 to 9 o'clock-ish on a Friday, on a Monday. And then we're going to sketch a graph. When we're sketching the graph, everything that we'll calculate should be on the graph. All right. So that this class is beneficial to all students, I'm going to do a question that I've never done with either groups before. So I'm starting here. So both groups are seeing this question for the first time. All right. Okay. So the function h is given by h of x cubed minus 3x minus 2. You see that ugly looking something there? It's not a problem. I'm going to tell what it means. 2 is a member of the set of real numbers. 2 is a member of the set of real numbers. So you're telling me, say, oh Jesus, forgive me. Not 2. X is a member of the set of reals. Means say, the values that I get from my answer is going to be a real number. I'm a member of the set of real numbers. And what are real numbers again? What do you put it? Odd number, even number, counting number, rational number, irrational number, prime number, composite number, all of the number system there, right? So they are a member of a set of reals. It says find the values of x for which h of x is equal to 0. Now, Keep students, yeah, you can do this too. Because what they're trying to do is to ask you, and incidentally, Cape students and CCCJ students too, they could ask you to go ahead and solve. But pretty much what they're asking you to do is to solve h of x, because them say h of x equals 0. You have to go to trial and error. Pre-calculus students, business calculus, remember that from pre-cal, where you have to do trial and error. And Cape students, remember the trial and error. That is going to be your homework. To do the section in blue. I'm not going to stop the class to do that. My aim today is stationary points. So you're going to do the section in blue. And then when next we meet, we talk about it. So we need to find the stationary points of h. What I want all of you to do for me is to go ahead and to differentiate the function. Find for me now h dash of x. All of you find h dash of x, and I'm giving you 1 minute to find h dash of x. No, I'm giving you half a minute to find h dash of x, and then tell me the answer you get. So what is the differential of h of x? Anybody, somebody?
3x squared minus 3.
Everybody agrees with that?
Yes, sir.
Yes.
Yes, sir.
Very nice. Laura, Tess.
Agreed, sir.
Nice. Colonette. Dwayne, you agree?
Yes, sir.
Nice. So it's 3x squared minus 3. Now, guess what? I finished differentiation, you know. I'm onto applications of differentiation. So if you catch it, 3x squared minus 3. Now that we differentiate it, Cape students, I'm not speaking to you now. Just go ahead and just look at the thing and answer the rest of the questions for me, please. I'm going through this with the Capes, the business calculus students. So Cape students, just go ahead and finish the question for me. If you're following what is happening. If you're not too sure, then you can swap over with the business calculus with me. Come business cal, this is us now. Now that you've differentiated the function and get 3x squared minus 3, I want you to set that to be equals to 0 and solve for the values of x for me. I'm going to give you 2 minutes to do that. Set your 3x squared minus 3 equals 0, solve for x, and tell me what you get for your answer. 2 minutes. All right, let's go. That's trial and error. I'm not doing the trial and error part of it. So my differential, I'm putting 3x squared minus 3 to be equal to 0. And then I'm solving. So I'm going to get x to be equal to +1 or -1. Did you get that?
Kind of, sir.
Kind of?
Sir, I
Okay.
forgot that way. The squared can be either positive or negative.
So you have to be very careful. It's not just +1. It could be -1 as well. Remember now, let me tell you one hint. When you are factorizing a quadratic, because it is raised to the second power, you may have two answers. So the mere fact that you only got one should tell you that something is off. The order of the polynomial tells you how many answers you're supposed to be getting. The order of the polynomial tells you how many answers you're supposed to be getting. All right? So let's go. So when I differentiate the function, so h of x is equal to all of this. When I find h dash of x, I'm going to get 3x squared minus 3. Then stationary point says supposed to set this equal to 0. Let me do it another way. So I can factor out the 3 from here, that I'm going to be left with x squared minus 1. And you should recognize this as a difference of squares. You should recognize this as a difference of squares. Let me see if I can write that. Come on, that's not what I want to write it. Yes. So you can recognize that as a difference of squares. And then that now will give you x squared minus 1. I'm going to solve x squared minus 1 and get x equals +1 or -1. Does this ring a bell?
Yes, sir.
Yes, sir.
All right, so I wrote it a little bit right there for you. So you can look at it like that. All right. So I'm going to get my critical values will now be +1 and -1. Okay, students, you see what I did right there? Does it ring a bell? Or what did the
Yes, sir.
factorization? Good.
Yes, sir.
Good. And this calc, I hope you see the same thing too. All right, so I get my critical values to be +1 and -1. See their critical values? So now, honestly now, when x is equal to +1, when I put in the +1 into my original function, remember now it's the original function? The original function. What's the original function, sir? Right here, so. That's the original function. So when I put in the 1 into the original function, I'm going to get 1 cubed minus 3 times 1 minus 2. And that's going to give me 1 minus 3 minus 2 is going to give me -4. And when x is equal to -1, I'm doing the same thing. I'm substituting, and I'm going to get -1 cubed minus 3 times -1 minus 2. -1 cubed is -1, but -3 times -1 is going to be +3 minus 2. So I'm going to get I'm going to get 0. So my stationary points or critical points or turning points, same difference, all of them, is going to be when it is 1, -4 and -1, 0. See them here? Right there, so. Take 2 minutes and look at that for me, please. 2 minutes and look at that for me.
So can you go up a little bit?
Sure. I mean, have to reduce it somewhat first. Right there is good?
Yes, sir. Thank you.
1 minute.
Sir, so you said the critical values are -1 and +1?
Very good. Those are the critical values. In order to find the critical points now, I'll have to substitute it into the original to find the critical points. But yes, you're correct. Give me half a second. Coming. All right.
Sir?
Yes, hold.
Sir, where you have 3 open bracket x squared minus 1, what happened to the 3?
What happened to this 3?
Yeah.
All
After
right.
that step.
Okay. This 3 is, it's neither here nor there because this 3 is either, let me put in that there. Sorry. How come you spell either, no Lord? E-I-T-H-E. So either. So this is what I'm having. So I'm having either 3 to be equal to 0 or x squared minus 1 to be equal to 0. Can 3 be equal to 0?
No.
No, sir.
So 3 can be equal to 0. So I throw that answer out.
Oh, okay. I get it.
That's a non-something. All right. So I'm just going to be left with x squared minus 1. All right. So since I put in that line, I don't need this line again. So you can just do that. All right. All right, let's go. So now I have my critical values. I want you to classify, what did the question say? The question said, determine the values of x for which A has a local maximum or a local minimum. So the question is telling me that, yes, one of them is maximum and one of them is minimum. One of them is maximum, one of them is minimum. So remember, in order to do this, the method that I'm teaching you now, business calculus, is the second derivative method. There's another method that I may not go into today. We're looking at the second derivative method. So I need to find the second derivative of the function. I need to find the second derivative of the function. And the second derivative of the function is going to be me differentiating the function one more time. So if the first derivative was 3x squared minus 3, when I differentiate this one more time in order to find the second derivative, see here, h double dash of x, the second derivative is going to be 2 times 3 is 6, so it's going to become 6x. And remember, the differential of a constant is equal to 0. So I'm going to be using the first derivative to differentiate it one more time in order to get the second derivative. And if I use the second derivative and differentiate it one more time, I'll get the third derivative, and so forth and so on. All right, so let me recap what it is that we've done so far. What we did so far is to look at the function given, the original function in h of x given. They asked us to find the stationary points. So what we're doing, we're differentiating the function. We differentiated the function and set the function equals to 0 after differentiating it and solve for the values of x. We got 3x squared minus 3 equals 0. We factored out the 3 and we're left with 3 times x squared minus 1 equals 0. Now we know that 3 cannot be equal to 0. That don't make no sense. That don't make no sense. So we know, so the only other one that is going to be equal to 0 is going to be the x squared minus 1. But we now recognize that the x squared minus 1 is known as the difference of 2 squares. From little school, we know that, the difference of squares. And when we factorize x squared minus 1, we're simply going to be getting x plus 1 times x minus 1. X plus 1 times x minus 1. And x plus 1 times x minus 1 is going to be either x equals to positive 1 or x equals negative 1. X equals positive 1 or x equals negative 1. Those two something are known as my critical values. They're not known as my critical points yet, or my stationary points, or my turning points. They are known as my critical values. In order for me to find the points, I must find my x comma y. So I have to find the y value corresponding to my x value to find the points. So anywhere in the original function I see x, I am going to substitute my critical values. Anywhere in the original function I see x, I am going to substitute my critical values. What do you mean by that, sir? Watch me. I am going to put x equals 1 into the original function, h of x. I'm going to put it in and I work it out. I can get -4, as is seen on the screen. I'm going to do the same thing with -1. I'm going to put -1 into the original function. Anywhere in the original function I see x, I put all of -1. When I put -1 inside here, it can work out and give me 0. It can work out and give me 0. Work out and give me 0. So my critical points, my stationary points, my turning points are 1, -4 and -1, 0. Is that those 2 points on the graph? Something going to turn. Either one turn up or one turn down. One is a maximum, one is a minimum. The maximum turns down and the minimum turns up. The maximum turns down and the minimum turns up. Maximum, negative, turn down. N for negative. Minimum, positive, turns up. Some students say maximum, sir, is a frown when you vex. The emoji, when you vex, and you send the vex sign, you have the sitting turn down, yeah. But when you smile, it turns up. I don't know if that helps, but I hear students say that. Frown, maximum, negative, turn down. Smile, positive, turns up. All right. So now we have our critical values. We are going to be doing the determining the nature of those critical values. Now watch me. We are now determining the nature of the critical values. So we're going to find the second derivative. We are given the first derivative. We are given the first derivative. We are going to be finding the second derivative. We're finding the second derivative. Now, in the first derivative, h of x is equal to 3x squared minus 3. Then the second derivative of x is going to be equal to 6x. The second derivative is going to be equal to 6x. So when x equals 1, sir, where you get 1 from? See it up here, so? It's a single variable function, so we have a y value in here to substitute. So when x equals 1, you're going to put 1 times 6 is 6. And that value is greater than 0, means that it's positive. So once it's positive, it's a local minimum. If it is positive, it's a local minimum. So I can tell you that the point 1, -4 is a minimum value. Let us try the other one. This -1. When you substitute -1 into here, 6 times -1 is -6. That's less than 0. It's a negative value. It's negative when it is maximum, or it's maximum when it is negative. So those are the, and the sketch of the graph looks like that. Now the value here, so the value here, so is going to be my maximum, because my maximum turns down and looks like an N. So that's my maximum. So this value here, so is going to be -1, 0. And of course, you can suspect that because over this side on the left-hand side of the graph is negative, and over the right-hand side of the graph is positive. So this value is going to be positive 1, -4. Let me see if I have my decimals open from last night. No, I don't. Let me look at my decimals graph. And oh dear. Give me 1 second, please. EESMOS. Oh, come on. All right, so I'm actually sharing. Are you seeing my graph?
Yes, sir.
Yes, sir.
Are you seeing Desmos?
Yes, sir.
Yes.
All right, good. So business calculus Desmos is an open source software that I love to use. Love it. There's an app version that you could download on your phone. I also have that, and I also use the web version. Open source, you don't have to pay for it. It's fabulous though. It helps to concretize the teaching and learning process. Really, really. Hold on. Complete. Directly. Any chapter. What if I mean I'm look for? All right. What was the function again? The function was x cubed what?
Minus 3x minus 2.
3x minus 2. All right. That's what the function is. Minus 3x minus 2. Now, when you look at the graph on Desmos there, you will see 1, 2, 3, 4 gray dots. Can you identify the 4 gray dots?
Yes, sir.
Those 4 gray dots are critical points on the graph. Those are points that you can calculate before doing anything else. Very important points on the graph. Now we got 2 of those points already. Look at that point. That point is a negative 1, 0. Can you recognize that point from what we calculate?
Yes, sir. Yes, sir.
Can you recognize this one?
Yes, sir.
Those are our critical points class that we would have calculated. And it tells us, hold on. Look here. So this is when Dwayne was driving to work, and he might drive and then remember saying, leave something, and he reach right to the him say, blow up, I forgot turn back. Him say, go drive the other way, come down here, man. He would have changed direction because look at what's happening. He is going up, 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 up. Him don't have no more up to go, so him have to go down, 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 down. And he continues going down, sorry. He continues. Oh, come on. He continues down until he gets to a point where there is no further down to go and he has to go up again, right? What I'm saying to you, this here looks like an N. Talk through. Don't this look like one N when you're right?
Yes, sir.
Yes, sir.
Yeah, man. So anytime you see one N form, it means that it's negative and it's a maximum graph. That one look like one N to me. And you won't see a textbook tell you that. I mean, when I do my work, when I go to school, I say, oh, I can remember the story of Jesus. And I say, but wait, that one look like one N. Yeah, man. And it has never left me. So this look like one N. Now, if this is an N and it's negative and it's a maximum point, that means the other one, the U, has to be the positive part. The U is positive. So this is going to be my minimum graph, and this is going to be my maximum graph. My maximum graph, my minimum graph. All right, my minimum graph. Now, interesting, very interesting, very, very interesting. And this one shows it up even more so than the others. Very interesting. Now, the point of the y-intercept. The y-intercept is wherever the function cuts the y-axis. Now let me just remember the function here. The y-intercept, watch me, look at this piece over here, so, which is my function. The y-intercept is anywhere x equals 0. The y-intercept is anywhere x equals 0. The y-intercept is anywhere x equals 0. So if this goes 0 and 0, what is the value of y?
-2.
See it here, so? 0, -2. That's my y-intercept. 0, -2. But that value shares another value that I'm going to teach you all know. Well, Cape students know it. I'm going to teach you business calculus, that other value. So I'm going to press pause on this, new share, and go to this. I'm going to press pause and then go to that. And that is going to be my point of inflection. Now look at what I want you to do for the point of inflection. For the point of inflection, I want all of you to do it. The point of inflection, you are going to find the second derivative. You're finding the second derivative, and you're going to set the second derivative equals to 0. You're finding the second derivative, and you're setting it equals to 0. You're finding the second derivative, and you're setting it equals to 0. You're solving for x. When you find the x value, you're substituting that into the original function to find the corresponding y value. Do that for me, please. Find the second derivative, set it equals to 0, solve for x, substitute the x value into the original y value or h of x value, and tell me what you get.
Finish, sir.
All right, talk to me now. So you would have calculated the second derivative, set it equals to 0. What it is that you'd have gotten. That wasn't a part of the question, you know. I am only now putting it in there because I plot the graph and I see what it looks like. So let me call this 5. They never give us a 5, but yeah.
You're talking about to get the Y-intercept?
No, man. The point of inflection.
Isn't the point of inflection the Y-intercept?
No. Why, tell me why I asked that question.
Sir, because the equation, sir, if you equate it to that of 1 for the line, the straight line graph that equals Y equals mx plus c, and then mx at the gradient plus c, so c would have be the Y-intercept, and that would have be -2, so I'm gonna put back -2.
All right, so that's why I asked you why you said that, because the point I was trying to make is what it is that you just figured out. I'm trying to show you that the Y-intercept in this case is going to be the point of inflection. In this case, Can anybody recognize, Cape students, can you see that? Because you know what the point of inflection is already. Can you see that?
Yes, sir.
So in this particular example, the point of inflection is going to be equal to the y-intercept, but the point of inflection is not the y-intercept. In other examples that we have done, Cape students, the point of inflection was not the y-intercept. All right? So that's why I'm saying that the question never asked us that, but I'm going to be doing it just to bring across that very point. So the point of inflection, you set h of x is set in h of x equals 0. So therefore, x is going to be equal to 0. Therefore, x is equal to 0. And then what you're going to do is to put x into origin into the original function. Remember, the original function is this. So anywhere in the original function you see x, you're going to put 0. I really want this point to be taken home, because I don't want. So h of 0 is going to be equal to -2. So the point of inflection is going to be 0, 2. The point of inflection is going to be equal to 0, 2. Now, let me just emphasize this point again. Business calculus, the point of inflection will not always be the y-intercept. I'm only doing this.
Sorry, you're supposed to have -2.
Thank you, Sudhi. Thank you. The point of inflection will not always be this. It so happens that it is. I recognize that. That's why I'm asking you to calculate the point of inflection. All right? So the point of inflection will not always be equal to the y-intercept. But in this case, the point of inflection is equal to the y-intercept. Sir, I hear you talking about the point of inflection and the y-intercept. I may understand the y-intercept, sir, but what is this point of inflection? Thanks for asking. So I'm putting back my new share up here. The y-intercept is where the graph cuts the y-axis. The graph is in red. It cuts the y-axis right here. So at 2, -2, 0, -2. See there? It cuts at 0, -2. That's where the graph cuts the y-axis. So that is known as the y-intercept. But the point of inflection that I just calculated, was the same value, 0, -2. So in this case, the point of inflection is equals to the y-intercept. Sir, what is a point of inflection? The point of inflection occurs between, at the midpoint, the halfway line between the maximum in this case, and the minimum. So it occurs between critical values or critical points. This is my maximum at -1, 0. That's my minimum at 1, -4. And my point of inflection is that point that falls halfway between. Now, if you never did believe me, say it's halfway between and it's the midpoint. Look here, so if from here to here so is 2 units, and from here to here is another 2 units. See here, so the amplitude is going to be 0 to -4. So the amplitude there is 4, meaning the height. And the Cape student should know what amplitude is because we did trigonometry already. So the amplitude here is 4. Business calculus, the height between these 2 points is 4. See here, so you saw 0 then 1, then 2, then 3. So no, -4, no, we don't call a negative sign in it, right? We just say the height of the graph is negative, is +4, or is 4. And half of 4 is 2. See here, it cut it right at 2. So I'm saying to you, the point of inflection is the midpoint between my maximum and my minimum value. All right? And in this case, the point of inflection equals the y-intercept. So does it always happen? No, it doesn't. In this case, it is equal to it. Let me ask 2 questions. Cape students, how are you now with this? Are you a little bit clearer? I'm happy I gave this question because I've never done one with you before where the point of inflection equals to the y-intercept. Are you understanding a little clearer, Cape students?
Yes, sir.
Yes,
All
sir.
right. You hear the question now.
Yes, sir.
Nice, nice job. Business calculus, honesty. Talk to me. Rockstone, when you stay, come on, talk to me. All right, you don't want to talk? I'll talk to you. Andrahan, how you stay?
Sir, I have a question. In terms of the videos that are posted on your channel, right? I checked it out and I realized that the work that you do is not reflected. It's actually not a video, it's actually an audio clip that is posted. Why is that, sir?
Right, so I don't know if you were here earlier. I don't know why that is so. The other videos, the other postings, you can see the video. So I was saying earlier in class today that it will be sorted out before the weekend is done. I don't know what is happening because quite a number of the last set of recordings that I've placed, not only for you, the Cape students are here, they too are complaining about it. And my Calculus 2 students are also complaining. I don't know what has happened. So I will seek help to get it rectified before the weekend is over.
Okay, sir, noted.
Yeah,
I am a different learner, sir. You wouldn't know that, but I learn differently than probably most people do. And a lot of things that I learn, I actually learn, being in the class, but eventually going in my own time and figuring out stuff. That's how my brain works, right? And so the videos would be important for a learner of my nature. But I follow you, sir. I follow you.
Okay, all right. All right. Tess, how you stay?
Sir, I'm coming up. I understand to some extent. Just need a little more practice and I'll be good to go. And I second upon what Mr. Reed said as it relates to the video and the trend learning.
Dwayne, how you stay?
Well, good so far, sir. Following.
Nice.
Just revisions and think I'll be there.
Nice. Diana, how you stay?
Okay, sir.
Nice. Calling it, you're not talking to me, no, miss. Damien, how is it?
Right, sir. Echoing the same sentiment like the others. It's just for me to get adequate time now at home to actually go back to the notes in which you have sent to us and also look on the videos as well in order to grasp it even better.
All right, let me not say that. I was going to say something, but I don't want anybody to think that I'm justifying anything. But no, let me say it. I want you to. So this is a new dispensation where we are learning in this form. Normally, the teacher will go in the face-to-face setting. And the truth of the matter is, if you don't catch it in the face-to-face, you don't have a recording to go back and catch it again, so to speak. So what I want you to do for me is, in as much as how important the videos, because it's not that they're not sent, they are sent, but it's just the audio that comes without the video. I don't want you to sit and say, I am waiting on the quote unquote video. You have Elicosoft, and I make it my point of view to send you the notes that are being used. So if it means that you're going to listen to the audio so that you can hear my annoying voice again while you're going through the handout, because the handouts that I send you are exactly what it is that I would have done in class to see how best you can follow, because I don't know what is happening. I really don't know what is happening. I am going to sort it out. But in the interim, there is Educasoft with their tutorials and assessments. There are my many handouts that I would have sent over to you guys. I think I'm up to maybe post number 3 or 4, if not 5, and just go through them. All of what it is that I would have done with you, I would have post those, catch up on it. Your mid-semester is coming. It is important. Your mid-semester carries 20% of your final grade. Educasoft carries another 20%. And it's just going to be very important. Very, very important. So I understand and I know and I agree that it is your right. If my other staff members don't send the recordings to the students, I am going to be very upset with them. I have sent them, but they're just not coming out as videos. But in any event, I would still want you to do your own preparations, and I don't want to hear say, sir, it's because I never get the video, but I never did do no work or I never understand. That should not even utter out of your mouth. I've given you notes, and these are things that I sit up and prepare either on the spot, like I did this morning, or prepare beforehand. I really want you guys to start and start now. You know the difficulties that some of you are facing. Work on those difficulties so that when the tire meets the road, you can sort out your stuff. Whatever difficulties you're having, we have a WhatsApp group. Drop it in the WhatsApp group. Sir, how you differentiate an exponential function again? And you ask me the question, or you don't have to ask me the question, drop it in the group. My calculus students, what them do? Them see something and then drop it. The CAPE students are like that too. I saw something come out and how we do this? This right? And then you have students who come out and typing and just doing the stuff. And then I look at it and say, very good job, keep up the good work. There are students in the class that are following. So if you're not understanding, how we differentiate an exponential function again? Somebody in the class must can tell it. Somebody can't tell it, then I'll come in and say, boy, the differential of the exponential function is the exponential function itself times the differential of the power, right? So let us use up the community. We're going to use everything at all angles. Your teacher, I try to make myself available, Lord Jesus. It's rough, but I try to make myself available. I've created WhatsApp groups. I have given you notes. I have given you Educasoft. I've given you the recordings. Yes, the recordings are not fully complete because of the videos, but you have 4 out of 5 things. So I expect you to still be doing your preparation. I don't know if you get my point, but what I don't want you to do is to sit and say, sir, I couldn't start because I wasn't seeing the video. I really want you to start because if we're in face-to-face, there's no video for you to get. All right? But I'm not putting water on what it is that you're saying. Yes, you have a right to get the videos, and I'm going to sort it out. If I can't sort it out this weekend, ICT Monday morning will have to go and sort it out. That will be their responsibility. I don't know if it is a format that you're doing or if it is that is my computer now, because my computer has been given some issues. I don't know, but I never used a computer, so that's not been an issue. I used the same device that I was always using to upload the videos, and they were always working. So it's not my computer. But anyhow, with that said, just to say to you that I want to bring home this point, that the point of inflection will not always be equals to the Y-intercept. Will not always be equals to the Y-intercept. In this example, the point of inflection is equals to the Y-intercept. It will not always happen like that. All right, we have 4 minutes. I have additional questions to send or to do. I won't necessarily start another question now because I know I don't have enough time. What I'm going to do with you is to give you an opportunity for these last 4 minutes or 5 minutes of the class to express to me either what it is that you're understanding, anybody, or what it is that is not so clear, so that I can know when I'm circulating your notes, business calculus students, a little later on today, I can bear that in mind, and then I can also send out something to the CAPE students so we can all be at the same level. What is it that is comfortable with you? What is it that is not too comfortable? Shoot at me now. I need to hear them. And I'm not going to call on people to talk to us. If I don't hear anything, I just going to say, have a nice day. All right, so let's go. Anybody?
One quick thing, sir. The mid-semester is week after next week, is it?
Yeah, I had an option to give you next week or the week after, and I decided that I want you guys to use the break to put in some serious work for the mid-semester. So yes, it's going to be after the break.
Appreciate it, sir.
No problem, Papa. There are no.
All right, sir, for me. Yes, sir. For me, I understand, most up to this point, this last topic here, sir. When you got to let's look back in the book. When you got to the part, sir, that said find the second derivative, set it equal to 0, solve for x. Right? I don't quite catch that part, sir.
Okay,
but
thank you. So
what might,
All right, no problem. Because you asked me, I'm gonna tell you. So one of the things that is very encouraging, I hear you say that you can draw for the book, and that's very good. So yes, when you find the second derivative and set it equals to 0, you're finding the point of inflection. All right. What I'm going to send off to you all, I think the calculus, the CAPE students already have this. I think I sent this off yesterday to them. Is my little narrative. I sat down and I wrote something for you guys, both CAPE and business calculus. Sat down and wrote something for you guys. The things to do. So for example, now Laura, I said to determine the point of inflection, you're going to use a second differential and set it equals to 0 and solve for the unknown. Then you're going to substitute the value or values obtained in one above, the one up here so, into the original function f of x, and you can write down the recordings, and that is going to give you the point of inflection. I even went as far as saying to you that the point of inflection really and truly is going to occur between two critical points. Really at the midpoint, and you would have seen it just now with the last example. It was very clear with the last example because the amplitude of that graph was 4 and the midpoint exactly at 2. So you saw that. And I want to say to you that if we have only one critical point, I can't have a point of inflection. One critical point can't give me the point of inflection, right? So it only occurs, and it only occurs when I have continuous function. So the function has to be continuous in order for me to be even talking about the point of inflection, right? What's the importance of the point of inflection? It just shows you the midway between the graph, because it's supposed to be symmetrical, and a continuous function. And in this particular case, you see where it is, that is equals to the Y-intercept. The question that I gave you didn't ask you for the Y-intercept either. Didn't ask you for the Y-intercept either. But yeah, I didn't answer for the Y-intercept, but the Y-intercept is going to be equal. All right, any other question? Thanks, Laura. All right, so if there are no other comments or points, TERCEPT, I will, go ahead.
I wanted to ask, what does the XER thingy mean?
What does the what?
The X and the, I think that's.
Oh, this?
Yes, sir.
It means that X is a member of the set of real numbers. X is a member of the set of real numbers. And you know what real numbers is. So it's nothing, it's nothing imaginary. So you don't have any complex numbers. A plus IB. You don't have any complex numbers in it. It's just real numbers that you have.
Okay, sir, thanks.
Right. So for the y-intercept, you're going to let x equals to 0. And then you're going to put x equals 0 into the original function. And then you can get the same thing like that. Please note in this PARTICUL particular example, the INTER, the y-intercept EQUA equals the point of inflection. It does not always occur. Very important. It's very important that you, so please note in this particular example, the y-intercept equals the point of inflection. It does not always occur. All right? So it's very important. I don't know why I'm spending so much time on this, but I don't want anybody to think that it's going to always be like that. Maybe because of the question that was asked, right? So in this one, both values are the same. Both values are the same. But it will not always be like that for the other questions. All right? Thanks for coming out. Have yourself a wonderful rest of the day. Peace.
Bye, sir.
Bye, sir.
Bye-bye.
Bye, sir.
Bye, sir.
Bye, and thanks for coming out.